In this problem, we have an example of the type of problem that you might see on the ASP or CSP certification exam. A problem requiring us to use Ohm's law to solve the problem and answer the question. Let's go ahead and take a look at the problem. Oh, and this, let me mention, this is how the problem could look. You'll have the body of the question, and they may give you a table that you have to use to answer the question also. In this table, we have the current in milliamps and the likely physical effects associated with each level of milliamps. So let's go ahead and look at the problem. A worker's wet finger having a resistance of 7,000 ohms touches a conductor carrying 115 volts. Now, it's not asking us for a number, it's asking us what the physical effect that we could expect with 7,000 ohms and 115 volts in this situation. So what we need to do is calculate the milliamps and then use the table to answer the question as far as the likely physical effect. So again, we have to do the numbers, we have to do the calculations, but the question is not asking for a number. Ohm's law can be used to solve this. The mathematics are simple. We need to find the current in amps using Ohm's formula, and we have everything we need to solve the problem. We plug the information into our formula to solve for I, which is current or amps. We plug in our voltage, we plug in our resistance, and then we can solve for I. We plug in 115 volts for our voltage, 7,000 ohms for our resistance. Now we need to isolate I, or current, on one side of the equation. The way we do that is algebraic transposition, very simple. We divide both sides by 7,000. And when we divide both sides by 7,000, it cancels over on the right side of the equation, which isolates current. And we end up, the next iteration, with 115 volts divided by 7,000 ohms equals our current. When we divide 115 by 7,000, we end up with 0.017 amps as our current. But we need milliamps. Our current is 0.017 amps, but we need milliamps. So we're going to have to do a conversion. Again, the effects table is in milliamps. So we need to multiply amps by 1,000. There are 1,000 milliamps in an amp. So we multiply amps by 1,000 for conversion to milliamps. And we end up, when we do that, with 17 milliamps. Now we can answer this question. What is the likely physical effect? We go back up to the table, and 17 is right in this area. It's not quite up to the level that we would expect asphyxiation, but we are likely to see muscular paralysis. It could be enough amperage that if the worker makes contact, let's say if they grab the conductor, there's muscular paralysis, they lock onto it and they can't let go, which could cause more damage because of the extended time of exposure to the current passing through the conductor. But again, that's a type of problem that you may see on certification exams. In your problem set, I give you a practice problem similar to this to work through. Let me know if you have any questions.